Hello and welcome to 5 Minute Math. Today we are looking at the 8.2D readiness practice, the advanced version. If you're interested in exploring the 8.2D readiness practice for the intermediate or proficient versions, or the 8th grade readiness practice for any other standard, you could find those by using the link in the video description. So we've got four different values here. We need to order them first from greatest least to greatest, and then we will have to find something else as well. So let's go ahead and order these from least to greatest. So I'm going to put some equivalencies up here. So pi, right, is equivalent to 3.1415. And since I'm going to go to the thousandths place, I'm going to change that 1 in the thousandths to a 2 because that 5 in the 10,000ths is going to raise that up. And I'm not using equal sign, I'm just going to use equivalent to. Let's do square root of 9.5. All right, so that square root of 9.5 is going to get me 3.082. All right, and then I've got 22 over 7. I think that's going to be an irrational number as well. So we will say, oh, that's very close. Right, that's kind of the closest equivalent to pi that we can get that's going to be, in that ratio form. That rational number is 1, 4, 2, 8. So we're going to make that 2 into a 3 because that 8 is going to change it up. And then we will do 3.14, which is just equal. Now we can do the equal sign, 3.14. I'll go ahead and make that have a 0 so we can go to the same spot. So let's put this on a number line here. And for our boundary numbers, let's make 3, and we'll do 3.2. So we'll have a 3.1 kind of midpoint here. So our smallest is going to be the square root of 9.5. That's below the 3.1. So I'll put 3.082, and then I'll put the actual value, square root of 9.5, right there. And then we get into the 3.14s. So I've got 3.140, 143, 142. So just look at the last three. Think of it like 140, 143, 142. If you think of it like that, it's going to be pretty easy. But 140 is going to be first. So I'll put the actual value up there, 3.14. Next, it's going to be right next to it. I'm going to have to bring it down here because it's too close. 3.142, which is pi. And then 3.143, which is the 22 over 7. All right, so first I need to go ahead and put these in order from least to greatest. Thankfully, when we put them on a number line like this, it automatically does that for us. Least to greatest. So I will say least to greatest as the answer key here. And I will say square root of 9.5. We've got, what do we have next? 3.14 pi, and then 22 over 7. Now, I also need to do something else. I need to find a square root of a decimal number. It's going to sit between the first and second numbers. All right, so here's my first and my second numbers right there. Well, look, if my decimal on the bottom end is square root of 9.5, all I could do is I could just take that to maybe 9.6, right? That would work. 9.7, that would work. 9.8 might get me a little bit too big. No, 9.8 would work. All right, so any of those would work. So I'm going to say answers may vary, definitely. Okay, and so I'm going to list this as decimal, and I'll just lift a few of these answers, right? So we said it could have been square root of 9.6, square root of 9.7, square root of 9.8, and obviously I'm just going to the tenths place there. You could easily take these to the hundredths place, the thousandths place, the tenths place, the 10,000ths place, right? So answers may vary, but those are some of the possible answers that could work for that second part. Now we'll underline that in green so we can see that right there. That's what we're trying to do. All right, so for our next problem, we've got four values. They're all negative. We need to have least to greatest. Let's get some decimal values here. And the first one's going to be pretty easy because negative 2.48 is going to be equal to negative 248. I'll put a 0. We're still going to go to the thousands place. All right, square root of 6. So what I need to do is I need to take 6, square root, and then just put the negative on that. Because if you take the negative, square root of negative 6, that gets into imaginary numbers. Not doing that quite yet. So negative 2.449. Because that 4 in the 10,000s is not going to do anything. Negative 12 fifths. So let's see what that is. All right, that's pretty easy. Negative 2.4, and I'll add some zeros. And then negative 245%. All right, so percent means per 100. So it's negative 245 over 100, or negative 2.45, because when it's over 100, you move the decimal in twice. To the left, there's no decimal. It always goes at the end. So these are my values. So it looks like everything is going to be between 2.4 and 2.5, but let's make sure we do it correctly here. Since these are negative, negative 2.5 is going to be farther away, right? That's less than negative 2.4, so it kind of goes backwards. So the least value is going to be the one that's farthest to the left. The farther you are to the left, the greater your negative number is going to be. So when you're in the negative, everything kind of gets reversed. So I'm looking for my largest negative value here because that's going to be my least number because it's farthest away from 0. 0 is way over here. So it's going to be 2.48. Looks like that's going to be it. So negative 2.48 is going to be my least number because it's my largest negative. Now I've got two that are really close. Look at that. Negative 2.450, negative 2.449, but the 0.450 is going to be bigger than the 0.449. So I'm going to do it's my midpoint actually. Negative 2.450, negative 245%. Okay, like right next to it. And so I'm going to draw kind of a line down here. It's going to be my negative 2.449, which is my negative square root of 6. And then I've got a little bit more room here for my negative 2.4. And that's my negative 12 fifths. All right, so let's go ahead and rewrite this from least to greatest. And my least is still on the left, greatest is still on the right, but in the negatives, my least is my largest negative number. So it's going to be least to greatest. And so that is going to be negative 2.48, and then negative 245%, negative square root of 6, negative 12 fifths. Now, the next part is going to ask me which charge has the greatest magnitude, the greatest distance from 0. All right, well, which one is farthest away from 0? Remember, 0 is way over here to the right. So my greatest magnitude is think of it like as the absolute value, right? If you take the absolute value of these numbers, which would be largest, well, it's going to be this one right here. So, because that's farthest away from 0. So we can say greatest magnitude. And we can give a little bit of explanation is farthest from 0. And if we want to use technical terms, we can say absolute value. And then the value is going to be negative 2.48. So there's my number, and there is my reasoning. Now for our third problem, we've got some expressions here. And interesting, two of them are exactly the same. And then we need to order them from greatest to least and explain why the difference between the two largest values is smaller than 1/10. Well, let's get some values. And since they've got them listed here, let's go ahead and just put our equivalencies off to the right here. All right, so this first one is pi. We're going to double it. Let's double pi. We're going to get approximately 6.283. Now, square root of 38 is approximately 6.164. It's not those two. 6.25 is 6.25. And then 24 over 5. There we go. That's the same. Okay, identify the pair. So first we can go ahead and say that these two are equal. One's a decimal, one is a fraction. Now we need to order them from greatest to least, so we can do that here. It looks like I'm going to be I'll make it 6.1 all the way to 6.3. I'll put 6.2 as my midpoint, and let's go ahead and put our values here. So my smallest is going to be 6.16, and that is going to be my square root of 38. We have 6.25. Now, this is where we need to say 6.250. I'm going to put two values here, right? 6.25 and then 25 over 4. They occupy the same space because they're the same distance from 0. And then I've got my 6.28, which is a little bit bigger. 6.283, and that is my 2 pi. All right, so now what we need to do is we need to explain why the difference between the two largest values is smaller than 0.1. What are the two largest values? So my two largest values, and so we'll say value is going to be 2.6.250 and 6.283. Why is the difference smaller than 0.1? Well, take a look at the values. That's going to the 10th place. So we can say the difference is less than 0.1 because both have the same exact 10th place value of 2/10. I'll put that in fractional form in the 10th place, or you can put that 0.2 if you want to. So since they have the exact same 10th, then any difference is going to be within the hundredths or the thousands. And as you can see, the difference here comes in the hundredths place. But by definition, the hundredths place is going to be smaller than a tenth. If the difference was greater than a tenth, you would see the difference over here in the tenths place. But the difference is going to be in the thousandths place or the hundredths place because they have the exact same value, 2 or 2/10 in the tenths place.